view how the web service adaptation is going on, where the web services is fitting into a web application. Gartner is advising companies to take up web services now or a risk of losing out to competitors. By 2008, those without web services or service-oriented architecture, that's where the entire web services comes into picture, would find their competitor had left them in the dust. 2006-7 would see the top 2,000 global companies pick up technology and make it mainstream. Government and small and medium business sizes are adopting these technologies by 2008. So web services is growing. Growing web services, some of the surveys done by SIIA and IDG says 79% of respondents said they will use web services. 77% say believe web services are critical to their organization. And 74% recognize that web services can deliver immediate business value. So this is essentially where we are looking at the web services would rocket from $1.6 billion business in 2004 to $34 billion business by 2007. That's the projection has been done. So this is essentially saying that web services is coming into picture in a web application scenario, which was not maybe a 2 or 3 years down the line. So web services is coming into picture. Web security and web service security is also coming into picture. That's where new opportunities, new attacks, new defense, new methodologies are coming into existence. Trends in web security, traditional attacks are weaker with secure web application framework. Old attacks of a path disclosure or a file source code disclosure and those attacks are no longer works. A lot of education out there, a lot of new products out there which are protecting that against these kind of attacks. Web application defense products and obfuscation provides a level of defense to web apps, but still the web services level is still coming up, it's still open. Web services becoming a part of application security. A lot of business houses are adopting web services at the back end, then front-end web application making calls to web services at the back end and such. The focus of attacks are shifting from web application, a traditional web application, to web services based application, and the attack scenarios are also shifting towards the same. Trends in web security. Web services security is growing issue. Toolkits and new exploits out there, which now people have started to use and test. Web services is a bit a complex technology compared to the traditional web application. So there are too many protocols, there are too many confusion, and these confusions is creating a loopholes in the system which you are adopting. There is a rush of implementation and a poor implementation can be seen on the field. So we are performing some of the web services assessment. We can see a lot of poor application implementation in a web services arena compared to web application. Causes attacks are growing with the growth in business usage. So this is essentially looking at the web services and web services security with a higher perspective. Now we'll start going into deep into web services. This is a traditional, if we are looking at the defense posture and how it has evolved over a period. Essentially, we had operating system level, services level, and application level, where operating system is covering IPC, WU FTP, Sun RPC, and such. If we come to a services level attacks, we have a web, SMTP, POP, and all those attacks happen there. Then comes the application level, where we are looking at a web application or customized web application which is deployed, which sits at application level. And the last level, which is a web services, which is called a business application level, which is something new, which is coming into web application integration part. So traditional attacks like a brute force, RPC buffer overflow, null sessions, all these attacks are essentially blocked by introduction of a firewall, VPN, IDS, and all those. So traditional attacks were no longer work. So the only opening which is left on an infrastructure or on the network is application level or a web services level. That's where the next generation attacks came into picture, like SQL injection, parameter tampering, and all those attacks came into picture. But with the invention or with the adaptation of application layer firewalls, for an example, mod security or a URL scan or app scan has a few products, there is a level of content filtering at HTTP and HTTPS has been observed, which is comparatively blocking some of the last generation attacks like SQL and parameter tampering. But The web services application level is still open. There is a hole with, there is no content filtering on a web services traffic at this point. So if you have a poorly deployed application at a web services level, which can be hit by these kind of a traffic. So web services attacks are growing. It cannot be stopped by firewall. It cannot be stopped by content filtering. Down the line, when introduction of a SOAP firewalls or other kind of firewalls comes into picture, at that point, a scenario may change. Very quickly, we'll look at the evolution of web application. Web application is essentially evolved with a simple web server running with maybe a scripted engine at the back end, and then it is taking a database into action and such. In the next generation, we got some of the application server out there, like a WebLogic, ColdFusion, as a need for a scalable application came into picture. So we got these application server. Then middleware components, COM, beans, etc. came into picture. And next generation, we got the application server and integrated frameworks like J2EE or .NET and such, which is the entire host is designed and developed for application hosting or a web application hosting. And now it is evolved or it is extended by a web services component piece, which is essentially designed and deployed on, for an example, on .NET, it is designed and deployed to serve web services, and it essentially works over a SOAP. A SOAP is another protocol which works over HTTP, and HTTP against work on a TCP. We'll see these in detail. So this is the current picture or a current technology scenario which we have. We have a powerful application server sitting which is serving a web services using different protocols. Now we'll move to web services. What is web services and what are the building blocks? Legoland of web service security has three entities or three key blocks. One UDDI, second is SOAP, and third is WSDL. We'll see how each one of this looks like. In very general terms, how web services work, before we get into web services security, I just want to clarify over here how the roles of these three blocks which we define. For an example, over here you have your UDDI business registry, which is like a common registry where you can go search what kind of a web services out there. Here is a web services consumer, and here you have a host 1 and host 2, which is essentially, hosting some kind of a web services out there. So as a web services consumer, or for an example as an attacker, or for an example as a person who is going to consume web services or looking for a web services, is for an example, web service consumer will query UDDI business registry. It will say, ask for service providers to registry. So for example, you are looking for some kind of a services which you want to integrate into your web application. You will go and ask a UDDI that what kind of a business services out there. So it will say, it will send the list of services to you, what kind of a services are available on a UDDI business registry. So around the world, everyone will, once they deploy a web services, they will go and register themselves onto these servers. Then you ask for access points. So for example, you got that there are 10 services are available. For example, you are looking for stock quotes. So there are 10 stock quote services for US market is available, for a Malaysian market is available. So then you will ask that where to access these services. So again, you will ask a UDDI that send me the access point. It is known as access point or address for these services. So they will send an access point or a service. In this case, we got the access point for a web services host 1 on internet. So now we know where the web service is located. Now this communication which we defined so far, which goes between web services consumer to UDDI business registry, that entire will go on a UDDI protocol. So that's where the role of UDDI sits. So first building block of web services is a UDDI. It is essentially between this and this communication will go on a UDDI. Now, knowing a web services, web service consumer will ask web service host 1, how should I access your services? So that will send the WSDL. We'll discuss this in detail. But essentially, it will send the WSDL. Once you analyze the WSDL, it will disclose the information regarding service methods, how you can access these services which is available, how you can go ahead and do it and such. In the next, once you have that WSDL, you can generate invoke methods using SOAP protocol. So we'll see how this is where a SOAP comes into picture. It will say it will send a SOAP request from web service consumer to web service, and in the response, it will get a response over a SOAP back with the result. So this is the way entire chain or entire cycle will finish. That you first search, you find the register, go to registry, find what kind of a service you are looking for. It will send you a service. From a services, you go ask which access point. So it will give you access point. From access point, you get a web services host address, access point where you can go and get the services. So you get that piece of information. Once you have that, you go there, it will send you a WSDL file. Looking at the WSDL, you can know that how to invoke each methods which is available on WSDL, and based on that, you can invoke those methods using a SOAP protocol. So this is a three entities game which we are looking at: the UDDI, one, WSDL2, and SOAP3. Now we'll move to web service technology. What kind of a web service technology you have out there? This how technology deployment looks like. You have a web services, web client, web server, and such. Here you have a three distinct blocks for web services. You have a web server, for an example, IIS or Apache running there, which serves SOAP over HTTP or HTTPS. Then you have application server like a .NET or a Tomcat or such, which will do essentially for you the XML parsing and such for a web services. And then you have a web service container where the Access and many other products out there which fit into a Tomcat server, or straight away .NET framework has ASMX model which will fit into uh, application server, and that is essentially where your web services code will reside. So this is how the technology deployment looks like. Now how it works, you have a web service consumer, then you have an XML router or switch by which web services generate a request which is XML based request. So essentially it has XML based routing schema and such. Then you have a binding XML methods, and that is also talking with a UDDI or a local or a remote UDDI from which WSDL schema or XSLT had been passed on. Then it will go to a parser conversion. It will convert your request or such. That where the invocation of code will go, and between this web service consumer to binding, a SOAP transaction or SOAP protocol works, and then the request will go to application server. Application server will call the application code which we are asked to execute. That will essentially make a request to a files or a database or RDBMS, wherever it's supposed to make a request, and then the entire response will go further back to the web services, web service consumer. So this is the way technology deployment looks like in web services scenario. Now we'll go into the methodology of a web services information gathering. So you start assessing the web services, where to start with. To assess a web services, first step to do a web services is an information gathering. Uh, a traditional information gathering can be compared with a web services information gathering. So there are four steps, which is a part of the assessment methodology we are looking at. First is a web services footprinting. Second is a web services discovery. Third is a web services technology identification. And a fourth is a web services profiling. So you start with first step, where we are saying that we want to do a web services footprinting. How we can identify where the services is located. We may know the company name in this case. For example, you know that you want to do some kind of a footprinting with Amazon. So you know the Amazon. Do we have any Whois server? We are traditionally known as a Whois server, where we can go and run a query that I'm looking for Amazon.com. So it will come up with the registry entry where you can find what kind of a DNS it has, who has registered, contact point, and stuff. So do we have any Whois server where we can go and footprint? If we answer above question, then we can have enough information to assess a web services which we are looking for. And the answer is UDDI. Yeah, you can do whatever task has been or a question on this page, we can do using a UDDI. UDDI stands for Universal Description, Discovery, and Integration. That's the protocol where UDDI stands for. It acts as a white, yellow, green, whatever page name you want to give. You have a yellow pages dictionary, you have a white pages, some part of the world uses a green pages or whatever. So essentially, that's where your dictionary is residing. It has several nodes: IBM, SAP, Microsoft. In the world, they have created their nodes. For an example, if you go to uddi.microsoft.com, that's the UDDI node for a Microsoft. Similarly, uddi.ibm.com and such. These business nodes are replicating with one another. So if you register at a one place over a 48 hours or 72 hours, your entry will be copied from Microsoft to IBM or IBM to SAP or such. So information can be published and retrieved. So this is where the public information, like a whois, comes into picture, where person can go query UDDI, try to find information and do such. It is get replicated across the network. So if you query one UDDI server, you can query other UDDI servers as well. Or it is not in replication mode, then you have to go each UDDI server and try to see someone has made entry, particularly the entry which you are looking for. Now, UDDI has a four models or a four entity. One is a business entity, second is a business service, third is a binding template, and fourth is a T model. So now you have a server which is serving the UDDI request. You have a client. You can go and ask what kind of information you are looking for. So for an example, here is the request and response, which will go from client to server, where we are looking for, I want to find a business where a fuzzy name is, say, Amazon. So what I'm doing over here is I'm generating a SOAP request, or I'm generating an XML block. We'll see this one in detail how it works, but essentially this is a way you can construct a request, like a HTTP request. You can construct this particular request and try, say, find business, generic, max rows and such, and you are sending the Amazon name back to the network, to the UDDI server, and then UDDI will come up with the entire list of whoever has registered something with business name in it, with Amazon. So you get the Amazon Web Service for testing, Amazon.com and such. So this is the way you can retrieve information from a UDDI for Amazon with a business name. So essentially we did a footprinting of a business name over here. The next, we are doing a footprinting for services. So over here we are sending the same request, but we are saying that find services. Last time we said find business name. This time we are saying that find services. We are again sending Amazon as a HTTP request. This is the way entire HTTP request get constructed on a post protocol. So it will go and give us entire list of Amazon web services which are registered as a service section. So there is one model is where a business entity get registered with a business name. Here we have a service name. We say Amazon Research Pen, Amazon Web Services 2.0, Amazon.com Web Services, Amazon Book Price, Amazon Book Price. These are the services which at this point registered with uddi.microsoft.com or any other UDDI server. So we footprint the services which has Amazon as a name. For an example, you are doing assessment on one of your clients, say XYZ Bank. Then you can go ahead and do these kind of techniques, or you can go ahead and try to query different servers, different UDDI servers, and you get this information back. And finally, you want to footprint with a T model, whether someone has registered anything with this name as a T model into UDDI registry, then you can give a name and a find underscore T model. So now you are querying UDDI database for a T model with Amazon as a name, and then you get the entire Amazon Web Services 2.0, WSDL and such. So this is what you get back. This is a small tool which I wrote, which will go out and try to query each UDDI server which I have specified and gather all the information and show me over here. Since I don't have internet connection, I can't show this tool. But essentially, it will go to Microsoft UDDI business over here, as you can see, and say I have given a WS footprint, Java WS footprint B for a business name, and then Amazon. So it will go and give me the entire Amazon portfolio, or with the Amazon business name, whatever is registered. And here you can see the key. This is a unique registry key which you get from each of this UDDI server. With this key, every services get replicated over the network with one another. So this is the way essentially I can footprint business name, I can footprint services, I can footprint T model and such. So this is a first methodology by which you can go ahead and do a footprinting. The traditional footprinting we used to do on a network is, say, we do a footprinting for a business name and try to find what IP address this company has. Maybe a class C, class B, what kind of a IP it has, what kind of a registration on a DNS name you have. You do LSD on a DNS and try to see the entire list of IP address and host names and such. So this is a similar web services footprinting. You can compare this with a traditional footprinting. Once you are done with the footprinting, the second part is a web services discovery. Once a footprinting web services, next step is to perform discovery. On the basis of services found, one can do so. So we have found, for an example, now we are interested in Amazon.com. What kind of a Amazon.com business name has services registered below them? So finding the access point for a web services, UDDI will just say you that this is registered or not. Then the next step is to find a discovery that where you can go and access these services. It is not going to. It is UDDI is not the place where services is hosted. It is just the address of the services. It is not the services actually hosting on that server. So discovery is the key to the kingdom. Once you have a discovery of the services, and if a services is alive, you can go ahead and do many more things on it. Once again, a discovery can be done on UDDI itself, since it, like name itself suggests, universal description and discovery. So now we can leverage the protocol which is empowering you to do a discovery. Once again, the same tool which do a discovery for us, where discovery is essentially we are sending the legitimate post requests with what we are asking for in a traditional HTTP format we used to do with a post and a buffer block. In this SOAP, we just have to do post with the XML message in it. So this is the way the server can understand and respond us back. So here what we are doing is we are doing a SAP, that's the last option, where we are saying footprinting services with access points. So now we want to find, for an example over here, what we are doing is we are doing a Java WS footprint dash SAP Amazon. So we are looking for something where the name Amazon is registered in a services section of a UDDI with access point. So now you can see over here we got the access point which is saying HTTP XSLT staging blah blah blah, and this is the where the research pen services is lying. Or over here you can say a soap.amazon.com schemas to Amazon web services.wsdl lying and such. So now you got the address to the server where this particular web services is located. So now you can go and try query this particular web services. You can try to play around with it, what it's doing. Your assessment will start from there. So you essentially finish with, or similarly over here what I've done is in a WS Disco tool I give a service key. So I pass a service key, it will go on the web, it will query each UDDI, and if any service key which matches with the service key which is registered in a UDDI, it will give me the access point for that particular services. So I get the access point for over here the 6 EC and such. So this is the way you can do a footprinting, and footprinting followed by a discovery. So now at a step 1 in the assessment methodology, what you have done is you have identified the company's name. From a company's name, you identified what kind of a business name are registered in a UDDI, what kind of a services are registered in UDDI, or a T model registered in a UDDI. Once having that information in place, what you have done is you have tried to query same UDDI for the access point. So now you have IP address or a host name where you can service or you can find this particular service which you are looking for. At the same time, entire URL where this services is located. So now you know that this is a place where you can go and actually access the web services you want to access. Once a web services discovery from various key services and a business, one can dig access point from a UBN, that's the Universal Business Node, or a UDDI business node from which you can get the access point. This is a part of a protocol and identified from XML block. So this is essentially, if you go into the RFC of UDDI, you can pretty much easily figure out what kind of a request you should build and send across to the UDDI, which will give you this particular information. Having these information in place, a third step of the methodology is technology identification. You have to identify which technology with which this particular web services is running with. So running on a which platform A, You can identify this from a configuration or a structure which you see on a URL, a file extension, a path discovery, or this is a very useful. So above is everything will fall into a very useful information. We'll see how it works. So over here, I have a small demo. For an example, you have a small DVD for less, a DVD web store, which is now has extended their reach. And this is a standard web store where you can go and buy CDs and such. It has a shopping cart and such. Uh, that is a web application, a traditional web application part. Now the web services part is, for an example, this section over here you see. There is a web services. This particular DVD store is supporting a web services now, which you don't use to support web services in previous. So for an example, Amazon is now supporting the web services on their website. So similarly, you can click the access point. So you will start accessing their web services, which will serve you the WSDL page. We'll see this in detail, but essentially, this is where you can find uh, access point, and you can go and try to see what kind of a technology it is running with. So for an example, in our case, we can find the location can be obtained from UDDI, which either we got the location of the web services from UDDI, or we just go to a website and click the access point, which is already on front page of a website. The access point is already given. Now, uh, knowing this information, for an example, this is the URL of the WSDL or the web services which we want to consume or we are looking at. Now you can see it is ending with a .asmx, which clearly states it is running with a .NET framework, or it is running, these particular server is running with a .NET technology, since you can start linking this information to already available information. Similarly, if the file is essentially ending with a .jws, then it is running with a Java web services. So you can say some kind of a web application server like a WebLogic, WebSphere or such, which is supporting Java's web services. Similarly, if in a path you get /ws, which is essentially stating it is running with a MS SOAP toolkit and such. Similarly, when you make a head request to a web server which is hosting the services, you get these kind of information which is saying X powered by ASP.NET. So you know that this particular server is running with .NET framework or ASP.NET technologies on it. Similarly, you can make a head request. In our case, for an example, web services is running /ws dvds for less.asmx. If I make the head request to it, I get another added tag, say x-aspnet version 1.1.4322. So this clearly maps that this particular service or this particular resource or a URL is serving by a backend web services engine. So we had three components in our model, which we discussed for, at few slides back, which is saying web server, application server, and then a web services engine or a container. So here is the XASP.NET version is essentially the container for it. Now, knowing this information, we know that where the business is located. We know from a name we got the business location. From a business location, doing some test like sending head or looking at the URL, we have identified what kind of a technology running behind application, what kind of application it is running with. Knowing this, first thing we get access is a WSDL. We will get the WSDL file from the server. That's the only information which we get at the first. So when you will try to access DVDs for less in our case or any other web services out on a network, the first information you get is a WSDL file, and WSDL file is XML block or XML information which looks something like this. It has several nodes in a properly defined hierarchy. So this is what the first key piece, or I would say very important place where you can do a lot of enumeration. What kind of a services is this? So what we are trying to do is the next step of a methodology or a next step which we're trying to perform is called WSDL scanning. We'll go and do a proper WSDL scanning. Now, WSDL scanning or enumeration, these are the key questions. Number one, what is WSDL? What information one can enumerate from WSDL? WSDL exposure is a threat or not? So answer this question. First is a WSDL is a web services definition language. If in older days, if you know the Corba, which is able to, you can make the remote calls on a Corba over a network. It has something called IDL, that's the interface definition language for a remote calls used in Corba. Similarly, to make a web-based or web services-based remote call, we have a WSDL. It contains details of methods, what kind of a methods this particular web services is supporting. For an example, there is a stock quote portal. So there can be a one method by which you can send the name of the company and it will send the pricing of the company. Or you can send, there is another method where you get the, you send the chart of the company, that this is the company and I'm looking for the entire 1 year performance chart. Then it will send that particular chart to you. So this is called, each of these is called essentially a methods. What kind of a methods this particular web service is supporting. Then comes the types of IO, what kind of IO it is going to perform. Then comes the parameters of methods, what kind of a parameters it takes as an input, what kind of a parameters it takes as output. Everything, it is an XML document which is going back and forth. So this is essentially a XML based a standard document which is defined in RFC, is a WSDL stands for. Now, very quickly we browse through how to do a scanning of a WSDL. There are several nodes in a WSDL. When you open a WSDL file, you see several nodes. Over here we have seen uh, several nodes. You have a types, you have a message, you have a port type, you have a binding, and you have a services. So these are the higher level WSDL node, a message type, operation, services, and access binding. Now we will find what each of them enumerates, or what each of these nodes will give you the information. First is the services. As soon as you get the WSDL file, just look at the services section. Forget about the other part of the section, because once you open a WSDL file and you're looking the WSDL file the first time, you will see the language you can't understand, because it starts with the messages, so you don't know what kind of a messages is this. But this is the way if you try to translate WSDL file, it will start making more sense to you. So first of all, we look for the services. We find that HTTP 192.168.11.2/ws DVDs for last.asmx. So this is whatever operation we do using this WSDL is going to hit this particular resources. That is a 192.168.11.2/ws DVDs for less. So it will give information that where the call is going to go. It is where a services is listening. Once we have that, go to a port type section. There is another section in a WSDL which is saying a port type. This port type will have the XML element called operation. So you have operation name. Looking at this three items, you can see that this particular web services is supporting three methods: introduction or intro, get product info, and a get rebates info. So this is the three key methods it will give. Once you have that, take this information and look for the message block. So in a message block, you have operation name, that's the get product info, which is mapping to get product info soap in and a soap out. So it will get what kind of a input it is going to take and what kind of output it is going to send back. Looking at this, you can now move with this information, you traverse to a type section, and in a type section you can find that get product info, that's which is the method which is taking parameter called name I equal to ID as an input, and the type of these particular ID is the string. And what output you are getting is a name is a get product info result, and what kind of a type of output you are going to get is a string. So now going step by step onto WSDL, first services, second port type, third message, fourth types, and then you can build your WSDL profile after scan. So now you have a profile that methods are intro, get product info, get rebates info, input is nothing, output is string, input is string, output is string, string. So now you know that this particular web services you are looking at has these three methods, and this is the way it works. So if we move over here, this is the way you can go to a services. You see the services over here. Then you can go to port type, where you can see operations over here, intro, then product info, rebates info, and such. Once you have that information, you go to messages where you get the intro SOAP in, what kind of a parameter is going to take, and that will define into types. So over here you can see introduction response. There is no introduction which is taking as input. The intro is just taking output. Or over here you can see ID and a string, get product in result and a string and such. So this is the way you have essentially profiled your WSDL after a scan. Now how it looks, you have a WSDL, you have a web services code or a class which has these three methods, that's the intro, get product, intro, rebates info and such, and then it is loosely binded with the WSDL, and any remote invocation or remote call coming to your web server will get processed in such a way. So now you have entire exercise which is already done, which starts with the company's name, ends with the entire profile you have from the WSDL. So for an example, here is a small web services client I have, which is saying .NET Web Services Studio is a client. Over here you can see I am giving the entire WSDL path. So I'm saying this is my WSDL path, go and do operation there, and then I say get. So we'll see this how it works in a later half of the section. But this is the way it will go: generate WSDL, generate proxy, generate assembly. You will see how it works. But at this point, I just want to show the one part once it gets over. So you specify the WSDL and say get. So it will initialize, it will generate so now you can see over here it has found three methods. That's the intro, get product info, get rebate info. If you go to get product info, then it will say it will taking string ID is equal to as input parameter, and if you send that particular parameter and invoke, you will get the output. So this is the way you can create the profile for the WSDL. So you have translated business name to your profile from WSDL. Now we'll see how SOAP works. From a UDDI, we got the information for access point. Then we analyze WSDL. The third step is if you want to talk with the server, which is listening to web services, only language or only protocol in which you can talk is a SOAP. And essentially SOAP, which works over HTTP or HTTPS and many other protocols. So how to access? Knowing WSDL profile, what is next? Accessing web services and see what goodies you can get and how. So how to access SOAP? It is called Simple Object Access Protocol. SOAP stands for. Invoking object on a remote machine, input output with remote objects. So essentially where we are looking at that there are many objects residing on an internet, and you want to access different objects in different methods. It is XML based messaging, work over HTTP or HTTPS, as well as it works over a few other protocols, like you can send your SOAP envelope using SMTP, or you can send your SOAP envelope using a FTP or such. It works on some other protocol, but the most popular way you get used is over HTTP or HTTPS, or rather I would say HTTPS. That is why firewall cannot block them. Attacks are essentially easy and possible. That we'll see how the attacks work. Then you have a SOAP request. SOAP request look something like this. You have the XML based request. You have a get product info over here. where you have to specify which method you want to invoke on the server, and then you have an ID over here which specifies which parameter you want to pass, and then you have an input method, you have a method call, and then you pass a value which you want to pass, and then you get the response back. So in our case, for an example, over here, if you look at the over here we have a few products here. For an example, this is a product one, the Finding Nemo, for an example. So we have a web store which has many products. Now this product is essentially you have to come to a website to see product, but if you are using a business objects, if you are using in a business, then you just have to, in a backend, you want to fetch this information. So that's why the role of web services or XML access points comes into picture. So for an example, similar exercise where we want to see a detail of product one, we can do a same exercise or a same information fetching using a SOAP or a web services. So for an example, we want to invoke and try to grab information for a product ID 1. So what we are saying is get product info, a string ID, and we say value. Over here we say 1, and then we invoke it. So over here you can see it got the output, and you have a string, a result, 1, Finding Nemo, the price is $14.99. So this is the way how one business is going to talk with another business. For the business application is not going to come on your website and manually or with the eye is going to see the product. So this is the way how you can invoke, for an example, Amazon's web services maybe going to use by millions and millions of different services, which is giving application which is going to go to a web services or Amazon and try to search it or try to see the pricing, try to see the ISBN number or such. Now, if you see what kind of a request and response went on the network, so here is on the top, you have the request which is saying XML version and such. This is a request which went from our client to a server, and this is a response which we got back. That's the 200 OK, get product result, Finding Nemo and such. So for an example over here, I change it to 2 and send. Then I get SOAP envelope and mail it to somewhere. That mail is also enabled by a SOAP analysis, so it will take the mail and send you the below envelope or a below information back as a part of the application. So this is on a various, it works on FTP, it works on SMTP or such. So this is the way essentially a SOAP envelope or a SOAP language or this mechanism works. So now having this information, we know that this is a SOAP request, this is the SOAP response, and how it works. So this essentially, we finished the 3 blocks of web services or web services security. That's the UDDI, WSDL, and finally the SOAP. Now, with this information, we'll move to a web services attacks. What kind of attack can happen to your web services? Once you launch a web services, what kind of attacks can happen to the web services? The first attack can happen is a WS web service address poisoning, which happens at XML or a router switch level. It is something like IP spoofing, or essentially it will make your routing switch router, the XML based routing is get corrupted, and it may hit to a certain application which is not in public domain or such. So one kind of attack which one can see is attack to a trusted application using XML address poisoning. The second is from a WSDL scanning opens many doors. From that, there are 2 kind of attacks can happen on your parsers or conversions, where a large buffer is injected. That's the buffer overflow can happen on your XML parsing routine, or a nested recursive load. Essentially, you try to create a nested XML nodes, one after another, and your XML is not capable of parsing that, then it will die, or some kind of a recursive payload can affect your application server. In that case, DOS on an application or crashing the server can happen. The third attack, which is a more traditional, the parameter tampering. It is essentially going to happen on an application code level, where it's going to affect it. For an example, over here, if we go to our application, over here you have a rebate section. So rebates is essentially this is a section which will say what kind of a deals are at this point this web store is providing. For an example, bandit like a Backham, you have a deal that if you buy one bandit like of a Backham, you get monsoon wading free, or uh, you buy a one monsoon wading, you get a one bandit like a Backham free and such. So this is the way how on a XML or on web services you want to fetch a similar information. So what you have to do is you have to send the deal name. That's maybe what kind of a deal name which you have to send from a rebates info. So over here you have a XML or you have a method which is called get rebates info. So whatever rebates info you are looking for, you can make envelope for it and send to the server, and server will respond back. So here you have a file info called a backham.html, and you can send that across, and then it will send the entire HTML block which application can analyze and come up with what kind of essentially what kind of a deal is on a backham.html or such. Now what if someone try to inject abx.xyz instead of a rebates.html? So what I've tried is on a file info parameter I try to inject abx.xyz, and this is what a soap fault I got. So this is where the poor implementation at application level, poor implementation at a source code level comes into picture, and it is saying the server was unable to process request ampersand greater than could not find file, then it disclosed the entire path. So or a ASP.NET framework or a .NET framework, this is a kind of vulnerability where it reveals the entire path of file you are looking for. Next, you know that this is some kind of a file operation. So in the next step, you go and try to access a rebates.asp itself. And then you get the file disclosure. You try to start retrieving a rebates.asp. So this is the way you start retrieving different files which are not belongs to you or you are not supposed to see. You were supposed to see just the backham.html deal. Instead of that, you start retrieving this file. So for an example, if we go over here and try to generate a rebates.info, and we are saying say for an example backham.html, and we invoke that, so we get the entire file. If we get request and response, so we send this particular information or a block of information, and this is the entire file we got back. Now for example I go for a junk over here and send a request, and now this is a response which I got from a server which says server was unable to process, and then it has disclosed the entire path cinet pub rebates.junk. So now if I try over here / rebates.asp and send, so I got the entire file or a disclosed file of a rebates.asp, the source code of a rebate.asp I was able to get. So this is the way you start walking out the web route, or you start walking out on a file system. So essentially you have bypassed the entire web server, application server code, and straight away you were able to access a file system or RDBMS or a database or such. So this is the way, if a poor input validation on the server, it may lands up of accessing a file system or such. So the one kind of attack which we have seen is essentially poor input validation attacks. The third is the SQL injections attack. From a WSDL scanning opens door, you get the SQL points. So for an example over here, we have a SOAP envelope where we sent number one product. We got the output of the product one, Finding Nemo. What if I send double tick or a single tick, which is going to be interpreted by SQL and may come up with something else. So over here you can see this is a fault code which I got, which says server was unable to process blah 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 column names. So this information will give me the idea that some kind of a SQL interaction at the back end. So now if I try 1 or 1 equal to 1, then I get all the products listed on that particular table. So this is where I did a SQL injection over a SOAP, bypassing web server, application server, and straight away hitting the SQL. And one can go ahead and do exec master XP command shell, which will run a command shell or exploit code on the on a application server or on a SQL server and come up with that. So for an example, if we go back to here and go to product info 1 and I say this invoke, so this is a legitimate request going. Now instead of 1 I go or 1 equal to 1 and send the request. So I got the entire query was executed, the SQL poisoning has been done, and I get the entire table content where there are 7 products out there. 1 or 1 is essentially always true, which is going to append it at the back of the SQL query and going to get executed. So this is a SQL poisoning over a SOAP. Or for that example, if I go here and semicolon, so I'm terminating the query of a SQL and give exec master. This is a known extended stored procedure residing on a Microsoft SQL server. So I say master dot xp underscore cmd shell. Then I give for an example dir c colon. I want to enumerate directory. So it's a kind of a remote command execution where I say inet pub root. So it's going to create a file for me saying dirc.txt here. It's going to create a file for me once this command get executed. So you have you got to get a product info 1, everything looks fine, but at the back end, if you go and try to see dirc.txt, then you can see the entire command was executed on a server and you get the entire listing of a file. So essentially over here, using SQL injection techniques over SOAP, you can do whatever you used to do over application server or other way. Yeah. Exactly. That's where the poor input validation A and a B poor integration of SQLs comes into picture. Now you have a two entity to manage. One is your front-end web application server where your normal HTTP code get executed, and then you have another code or a piece of code which is written for a SOAP. So if these two are not pointing to the same COM component or a function, then it may happen that there are two different implementation, and one implementation may be corrupt with SQL and other is not corrupt with SQL. But this is a completely different piece of code which with a different technology you have to write. So the code which you have already written in a simple ASP may not work in this case. But you are right, if there is a poor implementation and a poor bug, that's where we are looking at. So once you have the SOAP request, it worked. You can see you will get the admin privileges since XP command shell has the same. Now, looking at this, what is next is, for an example, you are assessing some application, a web service application. There are no many tools out there which will perform a web services assessment, and you want to create your own web services assessment tool. So here is I've given an example by which using a web services on a .NET framework, how you can create a tool. For an example, .NET framework comes with a tool called WSDL. So using this WSDL, you can create your own proxy code. So you can create your own proxy code using this WSDL. So for an example, over here, what I've given is a WSDL, then you give a namespace, for an example, DVDs for less proxy. Then you define a language, in which language you want to create the code or proxy code. This part is a little bit more understandable by the developer perspective. But on the fly, if you are doing the assessment and you want to do some kind of a stuff, then this is a nice tool, the way you can arrange. And then you give the entire path of where the WSDL is located. So once you have that, it will write a code called DVDs for less.cs. So it has created the proxy file. It has created .cs file for you. In the next step, you can see the DVDs for less.cs is created. This is a code of a proxy code, would look like something like this. And then in a proxy code, you will have a public string get product info string ID. So now you are dealing with, you have a higher level of abstraction. You don't have to worry about the SOAP protocol. You don't have to worry how the SOAP will work, how the SOAP call is going to make. You just have to take this CS file or a VB file or a .c file, integrate into your code, compile the code, and make the calls which you want to make. So once you have this public string, this is a small piece of code which I wrote using a namespace called DVDs for less, and then I said create an instance of a DVDs for less D4L, and then I invoke the property get product info and then pass the value to it. So it will get executed. And then you have a DVDs for less.cs, a one file, DVDs for less CS, another file, and then you use the CSC, that the compiler for a .NET, and compile both the files and you get the binary out. So for an example over here, if I go and say WSDL namespace DVDs for less proxy, I gave language C#, and then I gave HTTP. Just a minute. Okay, over here. So HTTP is 192.168.11.2. WS DVDs for less.asmx $WSDL. Now this works over a network. So if you have for an example, WSDL of Amazon or wherever in the world, the IP address and the entire URL. So if you execute this command, it will call the WSDL utility of a .NET, and then it will create a file called DVDs for less.cs. So if I say notepad, DVDs for less.cs. So here I have automated generated file, which is my proxy code, DVDs for less proxy, and I have a URL over here which is stating where it is pointing to, and then you can see all the methods here. So introduction method is here. You have here is your another method, public string, get product info ID and such. So this is the way automated fashion the proxy is created on the fly. Once you have a proxy code, you write your own code, which is a notepad call DVDs for less.cs. So now you have your proxy code. So you are saying that pointing to a using call DVDs for less. So that's the proxy code you are going to use. You have created a value which is going to be passed on a command line. You have a DVDs for less, D4L object is created. You D4L and then go for a get product info, system console, write results, and done. So once you are done with this, you can go ahead and do CSC, that's the compiling both the file, and do star.cs. Star.cs. So it will compile both the files and create DVDs for less, or DVDs called DVDs for less exe. So now if I go for a call DVDs for less binary, it is listening for some inputs. I give 1, it will get executed and I will get the answer, say 1 finding Nemo, or maybe 2, or I can go and do 1 or 1 equal to 1, or anything. So this is the way you can create your own proxy stubs and proxy code on the fly, run it, whatever assessment you want to do, you can do. So this is the way how you can create your own client code. Here we have just executed this one or one. Even you can, whatever exploit we want to inject, we have injected, and ipconfig.txt has been created and such. And if you make this request and start the sniffer on, you can see on the sniffer, you can see these kind of a SOAP request going from a client to server. At the same time, you have a higher level of abstraction. You don't have to deal with the information below. Another interesting thing which I used to do for the services, which is a TCP pipe creating, yeah. for a proxy code. The proxy code is essentially we created, the fundamental reason is there is no one tool out there which can serve to all web services. So for an example, if you are doing assessment or you want to assess Amazon's web services, then what you have to do is you have to create your own client code. Client code can be created in many languages using C, C++, VB, C Sharp and such. Now, first of all, when you want to create a client code, what you have to do is you have to create a proxy code for you. So which is essentially a proxy code is where you are saying that I want to make a get product info method. I want to use a get product info method. I have no idea about what kind of a SOAP request I have to send. So as a developer, this is an interface or a proxy interface or a proxy stub will give you power that you just have to look at the methods which you have, and the behind whatever code or whatever SOAP envelope is supposed to be created is going to create by this particular SOAP stub. So that's where the proxy SOAP stub comes into picture. Exactly. It'll make your job easier to integrate or do assessment rather than you don't have any fundamental tool and you want to construct every envelope by your own. Then you have to construct envelope, give it to a text message in a single line, calculate what characters you have to pass, and then you make a post request with that number of character to the server. So this is the way it's the easier way by which you can get power of doing such. And this is another example where, for an example, you want to see what kind of a traffic is going on and you want to manipulate the traffic, which we used to do using, in a web application assessment, we used to do using Achilles or a Paros. We just listen traffic in between, and before it actually hits to a server or it comes from a server, we just try to intercept. So over here, the similar exercise or similar can be achieved by, say for an example, I will go over here and I have to go to Notepad, DVDs for last.cs file. So over here you can see the target where this particular request or a proxy is going to go. It's going to go to this URL over here. This .url which specifies where this request should go. I comment this line out and I make sure that it listens to a local port. So what I'm doing over here is I say same URL localhost port 8080 for an example. So I have saved the proxy and I'm pointing up whatever traffic going from my client to a server to first hit 8080 of a local machine. So I compile this code. So the code is compiled. Now I start a listener. In this case, I just start a listener using a Paros, where the option is it is listening on 8080, and I'm trying to trap both request and response. So whatever my client sent to a server and whatever server I get before it hit to my client, I want to see what kind of a traffic is going on. And if I want to do some manipulation in the envelope, then I can do those envelope manipulation there. So now if I run the command and I say for an example 1, it will hit the Paros first. So now this is a traffic which is going from my client to a server, and this is the envelope where ID is equal to 1. So for an example, you want to do some kind of a manipulation over here, say 3, and then make sure that you change your local host to the target. So 192.168.11.2 is the target in our case, and then say continue. So it will get back and you have the third product which is Dr. Zivago 1099, and then you continue here. So now over here you get the 3. So this is the way you can intercept the traffic at the second level of assessment. So in an assessment process now you brought in your capability, you have advanced your capability for trapping the traffic, manipulating the traffic and such, making a very small change at your code level. So this is the way essentially you go and change, recompile the code, and then you can see what kind of a traffic it is going back and forth, and try to do all kind of a manipulation, proper assessment. You can do for each web services one after another, for each method one after another, what kind of, you may inject certain parameters, whatever you want to do, you can do that. Some of the other tools out there which you can use. Essentially, at this point, there is no one tool, so you have to make your tool. So there is a Mozilla browser comes with a JavaScript where it has a backend APIs for SOAP. Axis has API, Java native APIs, customization is needed. Web Services Studio, which I've shown, is also a good tool out there, which is developed by someone at Microsoft and posted on a Microsoft. It's essentially for a debugging application, web services application. It has some limited capability, but many times if there is a complex web services, then you have to write your own code for the assessment where the technique which I discussed comes into picture. And finally, there are some defense strategies for web services. Number one is a SOAP filtering. Regular firewall will not work. Content filtering on HTTP will not work either, since it is a SOAP over HTTP or HTTPS. SOAP level filtering and monitoring would require. Either you can write your own ISAPI level filtering, or there are few products out there in a market which does these kind of a capability where you can filter out a SOAP request. The second is WSDL hardening. WSDL is a major source of information. Should not have any leakage. Only provide the necessary methods. If there are two methods you are using, don't provide all other public methods, because if whatever you write in a WSDL can be accessed by anyone and can be attacked. Invoke everything over SSL and WSDL hardening thoroughly. Defense strategy 3, authentication and authorization. WSDL should have access control. Make sure that your WSDL is available to your clients or your suppliers or whomever you want to share this WSDL. Use SAML, that's the secure protocol for web services. Credential over a WS security APIs. Certificate analysis before you serve your rest of the envelope. So envelope, if you have implemented the certification, then envelope, the incoming envelope on the top, you have a certificate. So process that certificate before serving. Yeah. SAML is essentially a protocol where you can pass the certificate embedded in your SOAP request. So that's where the SAML, the markup language for security access control or authorization, comes into picture. So it is kind of a SOAP request, which we have seen is a completely simple SOAP request, but there are SOAP requests where there is a header section in a SOAP request which specifies the certification, what kind of authorization you have and such on the top. That's the markup part, and then you have the actual body of your SOAP. So that's where the SAML comes into picture. SOAP and XML filtering before access. So that's the third line of a defense. And a fourth is a secure coding, fault code management. Here we have seen the fault code which came up with the path disclosure or such. Exception handling was poor. Provide a proper input validation. SQL integration should not have flaw. Levels of coding, so use different components or different codes or different functions for each one of this. So if one compromises, the other doesn't compromise. And finally, defense 5, that is XML parsing. Make sure you are using a right XML parsing or a right XML parsing products out there. .NET and J2E has some issues, so if you are using those, then just patch the system. One of the issue which is emerging is a buffer overflow using a schema poisoning on XML. So if your XML engine is not coded in such a way that it can't parse multiple nodes or nodes more than 8 in a tree or a child fashion, then it breaks. So essentially, these are the defense strategy for hardening web services. So that's pretty much it. Thank you very much for listening to me patiently. Questions? So for the for a web services hardening, either you can block your brute force attack at the IP level. So what you can do is, if you know that this particular, for an example, web service is not going to access globally, for example. So you have 5 clients. So you can, if you all have a 5 static IPs, then you can block those IPs at IP level. That's the IP level defense comes into picture. And when you are talking about defense at application level, then you have to code your application in such a way that any attack, that's the application code which will keep monitoring what kind of a request has come and how many times it has come. So for an example, at application level, you can check for a 3 times username password didn't work, then 4th time it should not be entertained. So there are levels of defense you can provide. It is available for all of them. For a Java, you can use native API, or Axis has that. The Axis is an open source project from Apache, from which you can use straight Java calls. So that works pretty good. Any other question? My email ID is shreeraj@netdeskware.com. If you have any question, you can contact me. The presentation will go on a site, so you can access that as well. So that's it. Thank you very much.